Okay. Now let's recap quickly what we've done. This is a form of sheets, and we've covered all the kinematic stuff, special cases, projectile motion, tangent normal coordinate, and what's left is this radial transverse coordinate system. And let's get into it. Okay, for the third kind of coordinate system that we can use to analyze curvilinear motion, okay, it's called radial transverse coordinate system. Okay. Now we can split into two subcategories: 2D case and 3D case. 2D is called polar coordinate. For 3D, it's called cylindrical coordinate system, and they're very, very similar. Okay. And they're basically the same thing, just that 3D you have the third component. And for 2D case, let's say we have a particle traveling along this path, a curved path. I can use this radial transverse coordinate system, okay, or in 2D case it's called polar coordinate system, to describe the motion by radius, okay, r, coming from this origin, okay, this point of reference, okay, as well as if this particle is just traveling this way, then at a certain time later it will travel theta. So using r theta, that's essentially the 2D case of radial transverse. Okay? So in the r direction, the unit vector is called oops, the r direction. This is the transverse direction. R direction is called UR. In the theta direction, it's U theta. These are the unit vectors. In a 3D case, it's just very, very similar, except now U, R, and U theta, and the third component is simply the Z direction. Okay, it's like a cylinder. Okay, where you have a particle, then you can describe, the position by UR, U theta, and the Z direction, which is K. Okay, so from any point of reference, you'll be able to describe the position of any particle at any point in time. Okay, so let's focus on the 2D case, right, because it's more straightforward. Okay, there's a special relationship between UR and U theta. You can refer to the textbook for the derivation, but here's the result. The derivative, okay, of U theta with respect to theta itself turns out is negative of UR. Okay. The second relationship between UR and U theta is the derivative of UR with respect to U theta is U theta. Okay? So with these two relationships, that will come in handy in deriving the velocity and acceleration vectors, okay, for a particle under this coordinate system. Okay. All right. So let's get started. Okay. Now, we're interested in looking at three things here.